right, so we haven't officially hit chapter 4 yet, but there's an awful lot of it that we already know. If the alligator mouth is pointing that way, it means greater than. If it's going that way, it means less than. We know what greater than or equal to, less than or equal to. Equals equals, whenever you compare two values, an exclamation mark equals means not equal to. These give us true-false values, otherwise known as Boolean values. 12 greater than 5? Yeah, 12 greater than 5 is true. So if you did x equals 12 greater than 5, then when you were done, x would equal true. More commonly, we put these inside if statements, you know, so we don't wind up storing that value in a variable. But you could. So you can store your results of a Boolean, of a comparison, into a Boolean variable like that. Is x less than or equal to y? If it is, then result will equal true. If not, then result equals false. And again, you know, more common, we've seen these be inside if statements or whiles. The if statement, we understand what the if statement does. If it is raining, take an umbrella. If we have a lot of money in our pocket, go waste it. If it is cold outside, wear a coat, that kind of stuff. Flow charted like this. Is it cold outside? Sure is. Wear a coat. We've also seen if-elses. This does not have an else because there's no code that gets executed on the no side, only on the yes. Kind of veers off to the side if this is true, but if not, nothing happens. So there's no else involved there. You can put a whole bunch of things in the yes. You just put your if statement, you put an opening curly brace, you stack 100 lines of code there, and you put a closing brace. If statement notes. Do not put a semicolon after your if statement. I swear, I fix more of that than any other problem. Doesn't mean you're dumb, just means that you're used to ending every line in a semicolon, and so you want to put them there as well. If something, do something else. No semicolon there. Not after for statements either, or while. These are called control structures, and you don't put a semicolon on the line that defines the control structure, or else you short circuit it. If you had this line of code, if score is greater than 90 and you put a semicolon there, what that means is if score is greater than 90, do that. Do nothing. And then grade is equal to A. Well, grade would always equal A in that case. So by putting a semicolon there, we broke it. We made it always give the student an A, which they're happy about, but might get us in trouble. This says, be careful testing floats and doubles for equality. I don't recall if I talked about that, but if you're comparing two floating point numbers, very rarely are they exact. I mean, those floating point numbers can go out to like 16 decimal places. So what you normally do to compare them is you subtract one from the other and see if the difference is smaller than a certain value. You decide that, okay, these numbers are about the same if they're within 1/100th, you know, 0.001. Excuse me, 0.01, or 1/1000th, or whatever. So you subtract one from the other, and then you do an if based on that. We'll talk about more. Expanding the if statement. This is a block of code, as we know. That's the block of code that gets executed if the if statement is true. We can also make a block of code that gets executed if the if statement is false. The second path is tucked under the else keyword, like this. If expression, expression being a Boolean evaluation or a variable, that's either true or false. If that's true, then do this. Either a single statement or a whole block. Else, do that. And I'm kind of whizzing through this because we already know it, but feel free to go, hey, slow down. I want more talking. So that's a flow chart for an if. If this is true, if modulus %2 is equal to 0, that means it's an even number. You divided it by 2, you got no remainder. So print even number. Else, print it's an odd number. If there was no else, it would just go straight down. This wouldn't be here. That's how you know whether you're going to code an else or not. In this case, we would, because there's something on the false side, the no side, as well as on the true side, the yes side. Nested if statements. Are you employed? Yes. Are you a recent grad? Yes. Display, congratulations, you qualify for the special interest rate. If that's not true, you say you must have graduated from college in the recent 2 years to qualify. If this was false, if we're not even employed, it says you must be employed to qualify. Kind of mean, what if you saved a lot of money, you know, and then they're not letting you get the discount just because you're not working right now. But whatever. This is an example of a nested if statement. It's an if statement inside an if statement. That doesn't show you the code, but you can see. Here's your big if employed is equal to Y, and then you put an open curly brace there. And then you have another if recent grad is equal to Y, and you have another open curly brace there. You have some code there, and an else, and some code there, and then a closed curly brace, and then an else for that one. Hopefully that's the next thing. Here we go. This is called a nested if because it's one if inside the other. Like, you know, nested Russian dolls or whatever. If employed is equal to yes, great. We're going to check to see if they're a recent grad or not. If they're not employed, the code goes all the way down to this yes, and print you must be employed. But great, they are employed, so now we're going to find out if they're a recent grad. If they are a recent grad, we say congrats, you get the special deal. Else we say you must have graduated recently in order to get the deal. So that's a nested if. And you can nest structures inside of other structures. You can nest if statements inside of while loops, inside of for loops, inside of if statements. You know, you just keep indenting the code. One more version of the if statement. I guess I'm going to make some notes here. I mean, this is really elementary at this point. If you do something like if A is less than 10, C out, whatever. If else. If A, can I type? If B is less than 10, C out, 2, else, C out, 3. And then there's if, else, if. That sets up, this, you know, is either on or off. It either happens or it doesn't happen. This sets up a two-case situation. If this is true, we do one thing. If it's not true, we do something else. What if we have more than two cases? We've done that with that grade kind of program. If grade is greater than 90, if grade is greater than 80, whatever. So if grade greater than or equal to 90, C out A. I'm going to else if grade is greater than or equal to 80, C out B, else. This is a hard class. You get an F if you don't make an 80. There we go. So we can chain as many if statements as we want there, you know. If, else, if, else, if, else, if. You know, we could have 1,000 of them. If it's a particular type of if, else, if, we wouldn't be checking for ranges. We would be checking for particular values. Come on. And what do I mean by that? If A is equal to 0, do something. You know, C out 0. If I'm sorry, I keep going to Python. Else if A is equal to 1, C out 1. Else if A is equal to 2, then C out 2, and so on. You know, we could carry this on all the way up to 10 or 100 or whatever. You know, these are all discrete values rather than ranges. It has to exactly equal A in order for this to trigger. It has to exactly equal 1. I should have said 0. A has to be 0 for this. A has to be 1 for this. A has to be 2 for this. There's another way to write that, known as a switch statement. Let's come up with a slightly better example. C out, do you wish to 1, add, 2, subtract, 3, multiply. Like that. And then we will read that in. You don't have to type this. We will do something with a switch statement pretty soon. Read that into a variable called choice. If choice is equal to 1, they decided to add. Okay, let's do some adding. Else, if choice is equal to 2, they wanted to do some subtracting. Okay, let's do some subtracting. And then lastly, else if choice is equal to 3, C out. Let's multiply them. We can replace that with a switch. What the switch does is it sets it up. Well, here, I'll just write it as a switch, and you can compare them in your brain. Switch on this variable, choice. We're going to list a bunch of cases. Case 1, that means if choice is 1. Then C out, okay, add. But then we have to have a special keyword after that called break. We'll talk more about what the break does in a minute. All right, that's case 1. Let's handle case 2 now. Case 2. C out. Okay, subtract. Break. We've seen the break statement in loops before. We haven't seen it like this. C out, time to multiply. Break. And heck, let's throw in a default. If none of these are true, C out, I don't, or invalid choice, or whatever. That would just be like throwing in a final else up here. Else, C out, invalid choice. I'd like for these both to be on the screen at the same time. There we go. You see how these do the same thing even though the syntax is a little bit different? This is like saying, if choice is 1, do this stuff. Else if choice is 2, do this stuff. Else if choice is 3, do that stuff. Else print invalid choice. So functionally, these are equivalent. They would produce the same output except for the fact that I changed the text a little bit. That's what a switch is. It lets you compare a variable against a list of values. And if it matches those values, it'll execute that code. Now the break statement is important. If you leave it off, it'll go in and it'll do the next thing as well. So if choice equaled 2, but I didn't have that break statement, it would print, okay, subtract, and then it would immediately also print time to multiply. And if there was no break statement here, it might print invalid choice. I don't recall whether the default works that way or not, but I expect it would. So the break statement's very important. You almost always put it there. There are a couple times when you might not want it to be there. If that's true, comment it out and put a comment as to why you want it to quote fall through. It's called fall through. If choice equaled 1 and we did this and then the break statement was commented out, it would also do that. It would print okay add, then it would print okay subtract. If that was valid code, comment out the break statement, don't just leave it off, and then add another comment explaining why you do the fall through. Otherwise, the next programmer to come along is going to go, oh, that idiot, they didn't put a break. And they're going to put a break, then they're probably going to add, no pun intended, break your code. So a flag is a Boolean variable, could also be implemented as an integer, where if it's one thing, it's true. If it's another thing, it's false. Like an error state. Are we in an error state? True or false? Do we still have room on our disk drive? True or false? Are we still running the program? True or false? That kind of stuff. Logical operators, and, or, and not. I want to skip that because I'm in a hurry to get to our switch statement. The switch statement. It's used to select from several alternatives. Sometimes you can use them instead of if-else-if statements. Now, if the if-else-if statements are using greater than and less than, if they're checking for ranges, switch doesn't work. Why? It wants exact matches. You can't do this, case 1 to 2, and have it, know that that means that if the number's between 1 or 2. This needs to be an integer or some other discrete choice rather than a float or a double. You can't switch on a float or a double. It has to be something that can match exactly. Integer is the most common. Some languages will let you switch on strings. Some will not. I don't know if C++ does or not. Anyways, so characters, you could easily switch on characters, and ints, you can easily switch on ints. But you can't specify ranges. You have to specify exact values. So that grade program, greater than 90, greater than 80, greater than 70, wouldn't work very well. You could get it to work, though. You could do this. Say you have a grade that is between 0 and 100. What you could do is this. Int g is equal to grade divided by 10. That'll generate a number between 0 and 10. Because we took a number that went up to 100 and we divided it, So you could do this. Switch g, and if it's a 10 or a 9, they made an A. Case 10, case 9, C out, A. Break. And then if they made an 8, that was an 80. So we would C out B, and so on. Break. If we left the break statements off, it would print A and it would print a B. Just like when we did those else, we did those ifs, but we forgot to use the word else, it would trigger them all. So, and then lastly, if none of those were true, then the default is to tell them they made an F. Again, this is the harsh grading scale. C out, F. So here we got away with checking ranges by dividing by 10 and rounding it to a whole number. You're not always going to be able to do that, but for grades, our grading systems are typically, 80 and above's an A, 90 and above's a B, and stuff like that, so that would work. If you went to a rougher school where you had to make a 92 or above to make an A, then that would not work, because it would expect, if you divide 92 by 10 and got a 9, just wouldn't work. But for this, it works. Again, the point is that this has to be an int or a character or some other type that is easily, there's a stupid technical term for it, quantizable. It is something that is a discrete value. It is only a 10, or it is only a 9, or it is only an 8. It's not a 10.1 or a 9.2 or something like that.
The very last statements don't need breaks.
Correct. I don't think it'll hurt it if you put it there, but it's the last thing in the row, so there's nothing to do after it. So let me go back here. Whether there's a break or not, it's done at that point. Wouldn't hurt it. If you like the symmetry of seeing that, that's totally okay. Oops. Oh well. I launched Visual Studio, we may as well play with. So what we're going to do, what we're going to start, is you know how the letters on the telephone keypad and there are numbers on it. And back in the olden days, you know, all the phone numbers in Midwest City started with 73 because this was called Regent, R-E-G, and so the prefix for this area was Regent. And so if you gave somebody your phone number, you might say, okay, call me at Regent 43211, and they have to go, okay, R is a 7 and a C. Anyways, no, nobody does that, but that's the real reason why those letters were on there to begin with. You know, people couldn't text each other on their phones in the 70s and the 60s and the 50s, but they still had those numbers there once they invented touch dials, which I guess was in the 60s. So we're going to write a program that if they type in, which way do I want it to go? Because you could do it either way. Where if we type in an A, we'll print out a 2. If we type in a B, we'll also print out a 2. If they type in a C, we'll print out a 2. If they type in an M, that we'll print out a 6. An N would also be a 6, and an O would also be a 6. What would be an interesting little exercise there, in my mind, would be, do you remember what your flip phones, if you wanted to type an S, you had to hit 7 4 times? And if you wanted to do a U, you had to click 8 2 times. That'd be kind of fun to do, but we're not going to do that. If you want to, that'd be cool. Okay, anyways. So let's write a program that asks the user for a number. This is not a very good homework assignment. I used to have a lot more text explaining it. I guess I got tired of all that text. Let's crank open Visual Studio. File, new file. Empty project. I'm going to call it phone num or phone digit or phone letter. I'm just going to call it phone. We need our boilerplate, and we're going to include string. So I'm going to tack on # include string. Let's ask them for a digit. Cout, please enter a letter, not a digit. And then let's read that choice in. So string S, or string, I don't know, I'll call it digit, letter, string letter. They could accidentally type in more than one letter. So we're going to make it a string, but then we're going to pull out just the first character of it by treating it as an array. But first we need to read it in. CIN into letter. And now let's get that character out. CHAR, character, is equal to letter, but we only want the first position in it. So if they type in a bunch of stuff, we're only going to give them the first one. And by the way, you can get more credit on this assignment if you actually make it handle an entire string of characters. You would have to use a loop. We'll talk more about that. All right, now we have a character. We could do this. I'm going to write an if statement that does it, but then it's better if we do it as a switch statement. So on our phone pad, I have to keep looking at this in order to remember. A, B, and C are 2. So if CH is equal, and for characters you use single quotes. Oh wait, let's make that an uppercase CH so we don't have to check all uppercase and lower cases at the same time. So CH is equal to 2 upper CH. No uppercase letters in that, just all lowercase, 2 upper. That makes it uppercase, so it reduces the number of things that we have to check. We don't have to make a difference between lowercase a's and uppercase a's. So if CH is equal to an A, or, that's the symbol for or. Or means if any of these are true, we will activate. Or if CH equals B, or if CH is equal to C, in that case, let's see out a number, and the number that corresponds to this is a 2. And I just told you to put single quotes, and I typed double quotes all the way through. Let me fix that. I could do D, E, and F just by copying that code, pasting it, and changing it to D, E, and F and the output of a 3. So that's what I did. I copied those 3 lines of code, 2 lines of code. And I'm going to make this say D, E, and F, and output a 3. All right, that's doing it with if statements. We've done or and, is that correct? Feel free to shake your head no. I'm not seeing any heads shaking yes. I mean, I know that you Java programmers have already done it, but this symbol means or. It means that if this is true, or this is true, or if this is true, then do that. And that vertical bar is above the enter key. It's a shift / character. That's how you get the vertical bars. I'm just putting a comment here that the 2 bars means or. All right, that's how you would do it with if statements. And we could write a whole bunch of if statements. But we want to practice switch statements instead. I mean, I guess we could test this and run it and make sure it works before we do that. So please enter a letter. I'm just going to enter one that I know is going to work. D should print out a 3. All right, let's rewrite these as if statements. So a switch. So I'm going to comment those 4 lines of code out. I just want us to be able to reference them. All right, we have our character. CH is equal to 2 upper CH. Switch on CH. Switch on the value of CH. And if it's an A, so case single quote A colon, or if it's a B, case upper or single quote B, case C. If any of those are true, we want to C out a 2. And we want to break because we don't want to also print a 3 and then a 4 and a 5 and so on. Now Visual Studio defaults to putting the case in line with the curly braces. I like to tab it over, which requires some manual tabbing. All right, now we're going to handle D, E, and F. D, okay, it's getting even crazier. Where's putting the case? Okay, case D, case E, case F. We're going to print out a 3 and break. And then let's just stick on a default case so that if we didn't recognize it, we're just going to print that character back out. So default, if we don't even know what it is, we're just going to write that character back out to the screen. And after our switch statement, let's write it out an E and DL. All right, once you get that, run it, try an F, try a B, try something that's not up there like a Z, see what it does. F is a 3. C should be a 2. A Z, it doesn't know what a Z is, so it's just going to print Z out. Why would that be useful? Well, I don't feel like doing case 1, print 1, and case 2, print 2, case 3, print 3, That would be annoying to have 10 extra cases just to handle the digits. Why not just print it out if we don't recognize it? Because if it's not a letter, probably a number, or it's some kind of punctuation like parentheses or a dash, 737-4444. All right, now we didn't make this program loop and fun stuff like that. There's some real garbage in this assignment. I am going to rewrite it tonight. All right. Going. So here's what we've added. We added while true. We changed our cout statement to say please enter a letter or a period to quit. To handle that period, we did if ch is equal to period break. The reason I kind of shied away from sticking it in here is these break statements already do something different. They don't exit a while loop, they just exit the switch. So if I did case period break, it really wouldn't accomplish much. And then down at the bottom, we just needed one more close curly brace before our system pause. So please enter a letter or a period to quit. P. P. It doesn't know what a P is. Enter a letter, A. It does know what an A is. C. 2. Okay. What if you type in more than one thing? A, D. It just prints 2 because it only took the first character. And that's a big hint. You see this part right here? Character CH is equal to letter. You could put all of this in some kind of loop that would pull out all the characters one by one, and then run this switch statement on them.
Can you use the for loop to do that?
Yep. For while. Either way, you just need some way of making sure that when you got to that null character at the end of the string. I'm tempted to play with that, but I don't want to make this example more confusing than it already was. If this is working, you could continue on the assignment. Because I'm thinking that I want us to stop here and give y'all a chance to work on this. But before we do that, I do want to hit ands and ors. Two ampersands means and. If you use and, it means both sides have to be true. Like this. If A is greater than 10 and B is equal to 20. See out whatever. This will only print hello if both of these conditions are true. And means both conditions have to be true. Or means it works either or. So 2 bars means or means either condition, one or the other, or both, have to be true. So if C is equal to 10 or D is equal to 12, if both of those are true, excuse me, if either one of those are true, then it will do it. I hope that's pretty self-explanatory. This clause and this clause have to be true before it would print hello, because that's an and. This clause or this clause, even if that one's false, if that one's true, it's going to print goodbye. If none of them are true, it's not going to print it. Same is true for here. If A is greater than 10 but B is not equal to 20, it's not going to print hello, because this was an and, which required both of these clauses to be true. So feel free to keep expanding on this. I'll bring the graphic up with the letter keypad in a minute. This is the homework assignment, so you're working ahead if you go ahead and finish it now. All you'll have to do is add a whole bunch more switch statements. 8 more to be precise. I'm gonna make a Dropbox for this, but there's also gonna be a Dropbox in the homework, so make sure you upload today's work into the temporary, into the in-class, as well as the homework if you finish the homework. The only tricky one is P, Q, R, and S because it has 4 letters rather than 3. So can you guess why 1 or 0 don't have any letters at all?